last time we talked about like polynomials and then making these linear regressions and kind of measuring correlation with this R and some stuff like that, right? Yeah. Take out your calculator. Take a minute. Try to do number 12 here from the homework. I have it displayed on the border. You can read it off your sheet. Try to do number 12 here together. Or, well, I'll give you guys a minute or a couple minutes to do this, and we'll go through it together. But this chapter, as I've said, is very much like you need to be able to do this stuff on your calculator. So we're going to do some calculator practicing, make sure we can do this. Hi, Olivia.
Cleared my calculator yesterday. Can you do that thing?
The diagnostic. Yeah. So second,
okay.
And then catalog. I'll scroll down to the D's by pressing the button with the D on it. And then we're just going to look for diagnostic on.
Okay.
Select, execute.
Okay, thank you.
We're all good. You're welcome. If you don't have a calculator with you, I have a couple here that you can borrow if you need one. Luke, I'm looking at you, who doesn't seem to have a calculator on their desk. I only brought 2, though, so if there's more than 2 people missing a calculator, we're in a lot of trouble. I'm going to put one column in L1, the other column in L2. Personally, but again, you can put them kind of in any column you want, as long as they're in 2 different columns and you remember where you put them. And then tell the calculator where, remember where you put them so you can tell the calculator where to look. What's up? Sure, yeah, no problem.
Wait, I'm gonna take a picture.
What do you write after you type in all the information?
Then you need to do the linreg.
The what?
Linreg.
And how do I get there?
It's under the stat button.
That's the thing about the ratio, dude. If I hit the screen, you can just take it out.
What?
I just would stay to
Stack out Lin one.
Run it back.
Reg.
Wait, what do you put in sort
Y1.
Bars?
The bars. Y bars.
I'm probably gonna run this. But my deck is very.
Y bar?
4.4.
Pick that up.
Y bars.
Pop your partner.
Look, after bars,
Where are you at?
Y bars, right here, function.
Function and then one.
Um,
Calculate.
and these are the answers.
Yeah, and then you gotta find the 500 would be. You got bars, Y bars.
Bars,
Is that
Y bars.
function?
Yeah.
1 plug in 0.5 or do parentheses 0.5. Parentheses.
Y is 2.5. So, Mr. Kulik, when you put the 0.5 in after, like, into Y1,
Y.5.
that's why I'm asking.
For this 500, the elevation is in thousands.
There you go.
I didn't know.
Okay, what, and you continue. Olivia, you had a question after that?
Okay, yeah, so you, is that 5 or 0.5 in the beginning?
That's 5.
That was cute. The other one's cute as well. Wait, which one is
I think I tried to format it so there's a 0 point in front of anything that is a decimal.
Yeah, this is the same one. Okay, but this is the one I like.
So,
Might be
if
getting
5
an
is,
upgrade
if
for it.
it's in elevation in thousands of
Right?
feet, what would 5 like?
5,000.
5,000?
Probably Denver would be that city of 1.6 million at 5,000 feet, assuming it's a U.S. city. That'd be my guess.
I like this
Oh,
one.
and 500
Yeah,
divided
very
by
rocking with
1,000.
that. The other one
That's
has,
0.5.
the other one is jumping around in there.
It's okay.
The other one is jumping around.
I just want to
Jeez, the music get loud.
This one's like.
for real, just do not do that.
Dude, it's Stella's.
What kind of dog is that? They get big, right? Oh, it's not. They stay that small?
Now this one. This one.
So you should have gotten about, your equation should be like y equals negative 2.12x plus 13.23. And when you plugged 0.5 in, you should have gotten about 12.17.
Boom.
Yeah.
So just to run through the process again. So we typed in our data.
Okay.
We exit back out to the main screen. To get the linear regression equation, we press Stat. Go over to the Calc tab. Pick LinReg. Just pick the first one. There's 2 of them in there. They both do the same thing. It doesn't really matter. I type my x coordinates into L1. I type my y coordinates into L2. Frequency list is always blank. I'm going to store my regression equation because it's asking me to do something with it later on. It just makes it a little bit more convenient. So I'm going to store that into y1. So I'm going to press vars. Go over to yvars because I want a y variable. We're in the function mode and we'll pick y1. Then I'll hit calculate. So this is the information about my equation. So it's y equals, and then my a value is negative 2.12, x plus, and then my b value is about 13.23. Everybody's okay with that? On how I read this from my calculator? The r value here tells me what? My r value is negative 0.75-ish.
It's negative and it's on the stronger side, but not as strong.
Yeah, it's strongish negative correlation. Yep, that's good. Okay, with that. And now if I want to evaluate what the population, or use this model that I've created to predict the population when the elevation is 500 feet, I'm going to plug 500 feet into my function, but I have a units problem because the data that I use for the x coordinate is in thousands of feet. So I need to convert this into thousands of feet. So I'm just going to divide 500 by 1,000. And then I'm going to plug it into y1. So I'm going to go ahead and retrieve that variable y1. So I press vars over to yvars, function y1. And then I'm going to do 500 divided by 1,000. And press enter, and there's my 12.17. And again, the unit on that in the table is millions of people. So I'm going to go ahead and just say millions of people after the end. Or I could write it out with, like, you know, write as 12 comma 167 comma 000 or something. Like, that's fine too. You know, you can write it with as a million or whatever. Or you can just write the word millions after it. Either is okay. All right. What's next? I didn't bring my binder of notes. I have to use these things. So we've done correlation. We talked about linear regression. Okay. So linear models are not the only type of models that we can use to describe data. So we've talked about linear models. Today we'll talk about power models. Sure. Thanks, Bella. Other polynomial models, for example, like quadratic, cubic, etc. Exponential. And I'm trying to remember in the homework, did we do anything else? It's been too long since I've looked at these. Exponential. That's exponential. Oh, logarithmic, okay. Is there anything else? Cubic, exponential linear power, quadratic linear, exponential. Okay. Oh, logistic. Okay. So there's a third. Okay. Great. Okay. Logarithmic and logistic. So we have these other types of models. So we've seen linear already, right? We've talked about that yesterday. How do I compare against these other types of models, right? We talked about we can use R to describe like a linear relationship. But what about these non-linear functions like, you know, power, quadratic, or exponential? What do I do there? Well, remember when we did our linear regression here just a moment ago? And it spit out this R squared value. You haven't yet talked about what that is. So R squared is the coefficient of determination. Or that's what it's called anyways. And this is just a measure from 0 to 1 on how good a fit our model is to the data. So 1 is a good fit the closer we get to 1. 0 is a bad fit the further away we get from 1. So we can use that coefficient of determination to compare two nonlinear models and decide which one is a better fit. So it does basically the same job as R does between two linear models. Here we're going to be comparing like two nonlinear models, like a quadratic, something that looks like a U, and then maybe like a, like a exponential, something that looks like a hyperbola. Okay. So one in particular model that we're going to spend a minute just kind of talking about in general is the power model. So let me grab that definition here. Heck. This works so much better when I'm in my own room. Okay. All right. So a power function is just something that can be written in the form f of x equals k times x to the a. Now you might say, Mr. Kulik, that looks like a polynomial, right? What the heck is the difference? Well, here's the difference. The a in a power function is any non-zero real number. So in a power function, that a can be a decimal, it can be negative, it could be a fraction, but it can't be those things if it's a polynomial, right? So the power function is different because the exponent can be decimals and fractions and negatives, in which a polynomial can't. Everybody's okay with that? Okay. So just a little bit of vocab. The letter A, that coefficient A, we call the A is the power. K is a constant. It's called the constant of variation, or sometimes the constant of proportion. Let's see. We got an example here next. I keep pressing the wrong button. Yeah, there we go. Okay, so this is a vocab question. Let's do a quick little vocab example. So it says, here's the volume formula for a sphere. You may recognize that from geometry, you may not. Volume is 4/3 pi r cubed. It's asking us to find the constant of variation and then the power. So I remember that for a power function, that's f of x equals k times x to the a. Our equation is 4/3 pi r cubed. So what is like the independent variable in that volume equation? R, right? R is acting the same way like x does in the model. So what's the power? Okay, great. So the a is 3. The power is 3. And what's the constant of variation here then? 4/3 pi. Yeah, it's that whole thing is all our k, because all of those are constants, so they're all just part of k. Right? 4 is a constant, 3 is a constant, pi is a constant. They're all constants. The product of those three constants is just our value for k. Okay. Grab and do another little quickie example, another vocab primary example. Okay, it says write a power function for the given scenario. So again, as soon as I read that, okay. That's my base, right? So I'm going to be kind of designing my function to look like that. It says an object is dropped off a building. Its distance from the ground, so I call my function d of t, because it says the distance from the ground varies with the square of the amount of time that it has been falling. So t is my independent variable. That's like my x. And I have to figure out what I can fill in for k and a. So square is not the k, it's the, well, it's just t is the amount of time, right? That's the independent variable. Have we been given a value directly for k? No, not really, right? So I'm just going to stick a k out front, or maybe you write a 1. I would just leave it as a k though. Okay, anybody in physics right now? No? Okay. So if this is a object that's falling, right, because it's dropped off a building, why does an object fall? Gravity. So K would probably be the coefficient due to gravity. Anybody remember what that is? Or know what that is? So negative 10 meters per second. Yep, that would be fine. Or if you're in working with feet, I think it's negative 16 feet per second squared. Either one, that's fine. Now, do I expect you to fill in the negative 10 there? No, we're just kind of talking, right? If we're in a physics class, I would expect you to fill that in. But last time I checked, this is pre-calc. Hold on, check again. Yep, still pre-calc. Okay, good. All right, so next example. Says consider the data table. Use the data, create a scatter plot. We know how to do that, right? And create a power regression curve to model the data. Okay, we can do that. That's not hard. We do it the same way we do a linreg. We just pick a different reg equation from the same spot. And then use the curve to estimate the orbital period of Neptune, which is 4,497 gigameters from the sun. Okay? So we're going to go to our calculator. Where do we go to type stuff into our calculator? Stat. Edit. Great. I got to clear this stuff out of here, so I go up to the title. I press clear in the down arrow, and that'll wipe the entire column for me. Or you can just like type over things one thing at a time and delete any extras. That's okay too, but I'm not about that life. I'd rather get it all out of there first. So just going to go type this in. Again, I encourage you guys to follow along with me. It's good practice to just get used to where these menus are, what's in the menu, where the buttons are in my calculator. Because on the test and the homeworks and the homework quiz, which we might do after lunch, you'll definitely need to be able to use your calculator. I mean, this is the last section. for the chapter. No, there's no joking. That's why I said it right now.
It just keeps at least he's keeping it for real.
So there's typed in all my data, right? So exit out of here. Let's create the scatter plot part. Second, y equals, great. Turn plot 1 on. Option 1 is good. That's the points, the scatter plot. That's what we want. I type my x's into L1. That's great. My y's into L2. That's great. I like the little square because it's easy to see. I'm happy with all that. To get this to show up now, I'm going to do two things first. First thing I'm going to do is clear out anything I might have had in the y equals menu because I don't want that stuff showing up and uglying up my picture. And then I'm going to press zoom stat. So there it is, zoom stat, number 9. So there's my picture. Everybody's okay with the scatter plot? Yeah, we can see down here it's like most of that points are pretty small because we had to fit on that 10,000. In the same axis we have like 88 and 225, which are not real big in comparison, but that's okay. Now that I have my scatter plot, I'm going to exit out of here, and now I'm going to create my power regression curve. So to do that, I do it the same way I do the linreg. So I'm going to press stat, go over to calc, and I'm going to scroll down because I'm looking for power reg. There it is. I see it as option A, PWR reg. Works the same way linreg does. So I type my x's into L1. That's good. My y's into L2. That's good. We're never going to use a frequency list in this class. Never. And I'm going to store my regression equation into y1. So I'll press vars, yvars, function y1, and then hit calculate. So there, spit out my equation. So my model would be y equals 0.2 times x to the 1.5.
Can you go back to what you do when you put it into bars? Like when you hit bars and then you put in y1?
I just do vars and I press the arrow over to get to the yvars tab. And I pick function. And there's the y1.
And then after that, you put it, how do you?
What do you mean after that? That's just how you get the y1 for the store reg EQ.
Where is the store then?
Okay. So I've entered my data in my calculator. I press stat. I go over to calc. And I find the power regression option. So I scrolled down till I saw PWR REG. So for me, that's option A. Press enter. So L1 is where my X's were already, and L2 is where my Y's were, so that's fine. Nothing is ever going to go in the frequency list. And then where it says store reg EQ, that's where I'm going to put the Y1. So I press the vars button. Yvars, function, Y1, and then press enter on calculate. So that spits out my equation. So I'd write that down when it says the model, right? And that's just approximately, right? A is 0.2, so the coefficient is 0.2. The exponent is 1.5-ish. Okay with that? And then the question asks me one more thing. It says, then use that curve to estimate the orbital period of Neptune, which is 4,497 gigameters from the sun. So that's an x value. So I'm going to just plug that in for x. I'm going to use the y1 command to do that so that I get all the decimals and I get as precise of an answer as I can. It's the same idea as just typing this in without 4497 in the place for x. So I'll press vars, yvars, function, y1, and I'll do the parenthesis, just like I would a function notation where it would say, like, if I did f of 4497, it would mean plug 4497 into x. That's what this is telling me to do, or telling my calculator to do with the equation in y1. So the orbital period there would be about 60,150 days. That's basically how long a year is on Neptune. It's a pretty big orbit. You bring a coat? Is that what you said? Okay. Is it lunchtime here? Okay. We'll pause here. Out, and then we'll break for the homework quiz.
Is this going to be on the homework quiz?
No.
Mr. Bullock, before we take the homework quiz, can you go over another one of the problems from the first part of the homework?
Sure.
It's going to be on quiz.
So
No.
the last thing we want to talk about is, like, okay, say we're just given data and we're not told what type of regression to use, right? The problems we've looked at so far have told you to use linear, or told you to use power, or it'll tell you to use quadratic. What if you're not told? So in that case, we're going to look at the scatter plot to tell. If our data looks like this, so again, what we're trying to do is talk about how to choose what type of regression equation to make. If you're not told what to do, what we're going to do is look at the scatter plot. Let's say our scatter plot looks like this one. What shape does that look like? Straight line. So we should use a linear regression. Exactly.
But if it's like curved, then we would use like a power regression.
Well, let's go through the options, right? What if it looks like that?
It's what is it called?
Oh, quadratic?
Yeah, so that's a parabola. So the parabolas are what a quadratic is shaped like. So we'd use a quadratic regression on something like this. What about something like that?
Oh,
That's
Power.
a slope. No.
well, we just did that.
No,
Good try, Sia.
Oh, it has that as sinusoid?
Well,
Cubic?
since there's only two humps, not like infinitely many, I think this is probably cubic, where it looks like kind of two parabolas kind of hooked together, one opening up and one opening down. What about one like this? Some of this is probably going to be hard because we didn't get very far last year in Algebra 2.
Exponential.
This should be exponential.
Power.
Well, maybe, but like this would be logarithmic. We haven't done power yet for a reason. So this one kind of looks like an S. That's logistic. And then we haven't done power yet. Why not? Because it's kind of any of them, right? Power can kind of look like anything. It's like your most flexible one. Yeah. But it kind of any of them might be, power might be okay. Okay. That was the last thing I need to talk about in chapter 12. All right. Olivia, you said you wanted to do another problem?
Yeah, one from the homework that's gonna like is it gonna be like
What about these ones? Let's do these real quick then. 1, is this a polynomial?
Yeah,
Yes, why?
because all the numbers are real.
All the exponent values are positive whole numbers.
Your leading coefficient.
So that's a polynomial. The leading coefficient is 4. And the degree is 3, the biggest exponent. How about g of x? Is that a polynomial?
Yes.
No.
it's pi.
Yeah, the exponent is not a whole number. Pi is a decimal. How about h of x? Is that a polynomial?
Yeah.
Yes, all the exponents are positive whole numbers. What's the degree?
5.
5. And the leading coefficient?
Negative 7.
-7.4. It's the coefficient on the biggest degree term. How about k of x?
No.
No. Why not?
It's a negative exponent.
Well, it's more that you're in a fraction. That it's 1 over x, not x. That okay?
Yeah.
So there's like, it's kind of a nothing burger. There's no calculation to do. It's just like using a definition.
Okay.
What do you guys think? You ready?
Determine the type of correlation based on the graph. Positive. Positive. It's just positive.
And I would say this is like weakish, not super strong.
So what I say, and then that's strong
Do I
negative.
need to
Yeah. Strong negative.
do any like calculation
Negative.
for that stuff?
No, no calculator yet.
Okay.
Till you get like a table.
Describe correlation between I don't think so. Do we need to do the linear function that satisfies the column? Is that a little
I mean, all you're doing on that for 5 and 6 is I'm just going to make when I look at that, all I see is the 0.15 and then the 0.28. And then I'm just going to do a linreg on that. So y equals 3x plus 2.
Wait, so you did 1.5 and 2.8?
No, I did 1 comma 5 as a point, 2 comma 8. So I built a table in the stat, just like we did over here, with x's in one column and y's in the other column. Then I just did the linreg.
Oh, so you just did 1 and then 2 and then.
No, I did 1, 2, 5, 8. So x is in one column, y is in the other column. And then I did linreg on it, and it just spits out the equation. Or you could do like you did in Algebra 1 and like calculate the slope by doing like y2 minus y1 over x2 minus x1. And then like plug one of the points in and solve for b and put it back together again. But this is easy, right? That's the point of the LinReg is like, it's easy. Henry.
I've been using an online calculator. Do you have another one tomorrow?
The two that I had that borrowed that people claimed.
I'm ready to start.
I wish I had another one handy on me.
I'm ready to start too.
Can you do a ballerina pose?
That's blue.
Too current.
I know, yeah.
You gotta stay focused.
Henry.
You gotta stay focused.
Where do you go to?
Doing a little
sumo
sumo a little wide in the hip.
Take this key, go back to my classroom. There's two more calculators sitting on my desk. Can you grab them both and bring them back?
Thank you.
Is that okay?
Yeah.
You sure? You remember where the room is?
Yeah.
Okay. And you can use a key?
Yeah, I can.
Okay. I'm just checking.
Thinking the buttons on the one I've been using are just completely wrong.
Okay.
I don't know.
And then make sure you have the power on off.
What are you doing?
Oh.